Beams are acted upon by inclined forces. How to find out the support reactions? That is our next problem. Let us consider one beam acted upon by an inclined force of 8 kilonewton at 30-degree angle with the horizontal, and one UDL and another point load, and the supports are a roller support and a hinged support. The distances are, the inclined force is at 2 meter from end A, and the UDL starts at 2 meter from that of 8 kilonewton, and its length is again 2 meters, and the vertical load 8 kilonewton is at 1 meter. Then this is also 1 meter length, and this is 5 kilonewton per meter. 5 kilonewton per meter. So this is the problem. So in this case, as there is one inclined force, it will have a horizontal component also. Okay, so it will have both vertical and horizontal components. So when we draw the free body diagram of this beam, it will be like this. It will be like this. So at the roller support, we know only one reaction will be there, and it will be vertical, and let it be RA. And at the hinge, RB vertical component and one horizontal component. And to determine the direction of this horizontal component, we will have to assume that is, in this beam, whole beam, only one force is there in an inclined position, that is 8 kilonewton. It is acting in this direction at 30-degree angle with the beam. So its horizontal component will be trying the beam to push in this way, that is from right to left. So in order to keep this beam in equilibrium, this reaction, this horizontal reaction component must be in this direction. Okay, or suppose you are taking this in the other direction and you are calculating. If you are doing it correctly, you will get the direction of this, or the magnitude, as minus, negative. So RBH, you will get it as minus, say some value, say 10 kilonewton or 15 kilonewton, like that. That means if you have shown the direction in this way as RBH initially, and you are getting the value as minus RBH or minus value, then you should realize or understand that the force, the direction we have assumed is in the opposite direction, and you have to show the direction of the force as in this way. Okay, now we will show the other forces. For the 8 kilonewton force, these are the components. This is the horizontal component, this is the vertical component. This will be 30-degree angle, and this will be 8 cos 30, and this is 8 sin 30. Okay, and the UDL is converted into point load as the intensity into distance length, that is equal to 10 kilonewton. 5 into 2 equal to 10 kilonewton. Then this force of 8 kilonewton is there as such. So these are the forces acting on the beam with the inclined force resolved into two components, that is vertical and horizontal components. This will be minus, as you know, and this will also be minus. We will put it in the equations. So this distance is 2 meters. This is 2 plus 1, 2 plus 1, 3 meters. This is 1 meter, and this is also 1 meter. Okay, now we will apply the equations. Say sigma h equal to 0. First equilibrium equation, sigma h equal to 0. How it will be? Two horizontal forces are there on this beam, that is 8 cos 30 in the leftwards direction and RBH in towards right. So RBH is taken as positive, as it is acting from left to right. RBH minus 8 cos 30 equal to 0. So from there is no other horizontal forces, so you can directly get RBH equal to 8 cos 30. So RBH is equal to 6.93 kilonewton. So we got it as positive. That means the direction we have assumed is correct. So that is RBH, the horizontal component of reaction at this point. Actually, the reaction at B will be, this is A and B, reaction at B will be at an angle with the horizontal or vertical, and that reaction is having components of RBH as the horizontal component, RBV as the vertical component. Okay, and we will find the reaction, the net reaction or the resultant of these two later in the end. Now next we will find sigma V equal to 0. Sigma V equal to 0. How to find out? Sigma V, there are how many forces? 1, 2, 3, 4, 5 components are there. 5 components are there. So we'll start from RA. RA is in the vertically upward direction, positive, minus 8 sine 30, minus 10, minus 8, then plus RBV, because it is acting in the upward direction. So when you simplify this, you will get RA plus RBV is equal to 8 sine 30 minus 10 minus 8. Okay, so it will be equal to 22, 22. Let this be equation number 1. Let this be equation number 1. Then we have two unknowns, RA and RBV. We need one more equation. For that we will use the equation sigma m equal to 0. Sigma m A equal to 0. When you apply sigma ma equal to 0, it will give you, we will take moments about point A. Moments about point A. So the forces which make moments are, RA will not make any moment, this will not make any moment because it is acting along the beam, and RBH will also not make any moment because it is also acting along the beam. There is no perpendicular distance between the point and the line of action. Line of action is through the point itself, so there is no moment for RBH and 8 cos 30, and as it is acting through, even though it is vertically vertical direction, it is acting through the same point, there is no moment for RA. So the moment making forces are, components are 8 sin 30, 10, 8 and RBV. Okay, So 8 sine 30 will be making a moment of clockwise moment, and normally we take clockwise moment as positive. So 8 sine 30 into perpendicular distance is 2 meters, 2, then plus 10 into 5, the total distance is 5 into 5, then 8, this total distance is 6 meters. So it will be plus, it is also in the clockwise direction, 8 into 6, and RBV will be making anti-clockwise moment because it will be trying to rotate the beam in this direction, anti-clockwise direction. Therefore it will be minus RBV into 6 plus 1, 7 equal to 0. Okay, so this will give you, that will give you 8 sine 30 is 4 into 2 plus 50 plus 48 equal to 7 RBV. Okay, so this will give you 106 equal to 7 RBV. From this you will get RBV equal to RBV is equal to 106 divided by 7 equal to 15.14. So RBV equal to 15.14 kilonewton in the upward direction. So once we get RBV, we can find out RA from equation number 1. So equation number 1 will give you RA equal to 22 minus 15.14 equal to 6.86 kilonewton. 6.86 kilonewton. So RBV equal to 15.14 and RBH is equal to 6.86. Okay, so at this point B, what happens is, this is the beam and here is the support. Okay, here is the support. So what is happening is, actually here the forces will be acting, the reactions components will be acting like this, and it will have a reaction like this. So this is actually RB, this is RBH, this is RBV at an angle of theta, at an angle of theta. Okay, or I will draw it here. That is, assume that this is end B drawn in detail. So here the forces will be acting like a vertical component and a horizontal component, R, B, H, R, B, V. So this is to be we need to find out the resultant of these two components. That means here will be, this will be RB. That means the reaction will be acting like this. This will be the reaction, and this will be the angle theta. This is RB. So RB is equal to sigma R, RB is equal to R B H square plus RB V square. So this is equal to RBH. What is RBH? RBH is 6.93 square root of 6.93 square plus RBV is 15.14 square, and you will get the value of RB. To find out this angle theta, we should find theta equal to tan inverse RBV divided by RBH. When you substitute the values, you will get the value of the angle theta in degrees.